Hello everyone, and welcome to the first video in the binomial distribution series. We're going to talk about what constitutes a binomial distribution. We're going to introduce the formula and we're going to discuss the charts. First, we're going to talk about the criteria needed to qualify something as a binomial distribution. Firstly, there has to be two possible outcomes, which we'll call success or failure. However, you do need to remember success isn't always something positive. It could be a blown tyre. So success actually means this thing happened, and failure, this thing didn't happen. Next, the number of trials needs to be fixed. For instance, if we were rolling a die, we could do 5 trials and roll it 5 times. The third criteria is that each trial must be independent. For instance, if you do a survey and phone 50 people to find out if they enjoy flying, it doesn't matter what the first person answers, whether it's yes or no, it doesn't affect the answers of the subsequent people that you telephone. And finally, the probability of success must be the same from one trial to the next. For instance, if you're tossing a fair coin and the probability of getting a heads is 0.5 for the first toss, it's also 0.5 for the second toss and the third, etc. Now, the graph of a binomial distribution will usually look something like this. So binomial distribution will usually be represented as a bar chart, and as the number of bars increases, it becomes more curve-like. The bar chart is often symmetrical, but it can also be asymmetrical, and it will only have one peak. Also, the number of successes will always be written on the x-axis, and the probability will always be written on the y-axis. And if you add up all the probabilities for all the bars, it will equal 1. So now let's look at a couple of examples to find out what is a binomial distribution. Remember, there are only two possible outcomes, success or failure. We have to have a fixed number of trials. Each trial must be independent of each other, and the probability must be the same for each trial. If we count the average number of cars travelling down the high street between 3 p.m. and 4 p.m., is that a binomial distribution? Straight away, we know this isn't a binomial distribution because there aren't two possible outcomes. There's no success or failure. We're just counting the average number of cars. So we can discount that one, but what about if we count the number of kings we choose when we pick 8 cards from 2 randomly shuffled decks? Well, this one looks a bit more promising. Now here we do have success or failure because success is choosing a king. We also have a fixed number of trials because we're picking 8 cards, so we have 8 trials. However, are they independent? Well, no, they're not, because if we pick a king, the next time we choose a card, there are less kings to choose from, so they're not independent of each other. And also, the probability of picking a king has changed, so it doesn't qualify for the third or the fourth criteria. And in the last example, we survey 100 people to ask if they shop at Jerry's supermarket. Well, in this example, there is success or failure because success is if they shop at Jerry's supermarket. There's a fixed number of trials, which is 100 because we're surveying 100 people. They're independent of each other because the answer from one person does not affect the answer from another person, and the probability is going to be the same for each person we ask. So this does qualify as a binomial distribution. Next, we're going to go through the formula and describe what each term represents. So capital X is a random variable, and small x is the number of successes we require. N is the number of trials, or the number of experiments performed, or the number of people surveyed, and P is the probability of success in each trial. Now we're going to use a real-life example to put some values in. So we're going to choose the experiment of tossing a coin. We can have a heads or a tails. So using this example, capital X is tossing a head and small x is the number of successes. So in this case, tossing a head 4 times. N is going to be 10 in this case, as we're going to toss the coin 10 times. And assuming this is a fair coin, the probability of tossing a head and a tail is equal, so P is equal to 0.5. So now, to find the probability of tossing a head 4 times if we do 10 trials, we put the numbers into this equation, and that is the same as finding the height of this bar. This is the equation written down with all the values put in. Now for the first bit, 10 choose 4, we can use the combinations formula, which is here, and we end up with 10 factorial over 4 factorial, 6 factorial. Then we have 0.5 to the power 4, which is 0.0625. Then 1 take 0.5 to the power 10 take 4 is the same as saying 0.5 to the power 6, and that is equal to 0.015625. So the probability of getting 4 heads if we toss a coin 10 times is equal to 0.205. We're going to look at the binomial formula in more depth in the next video, but for now, thanks very much for watching as always, and I really appreciate it if you could hit that like button. So thanks very much guys, see you soon.